Hello and welcome to my YouTube channel. So before the year 2020 finally passes away and we are greeted with 2021, I thought I'd make another tech-based video in order to give farewell to this very troublesome and overall hard year for many people. What you see in front of you is basically my homemade pump that I have been using for quite some time to move liquid from one big canister to a smaller one. So its primary use was to pump heating oil. But this one in particular hasn't been used for almost, I think, 5 years, 3 definitely, and its original inception or design has changed a little bit. As you can see, I've made everything very nice, and that is because I'm trying to get rid of this. Even though its primary purpose was to pump heating oil, it can also be used to move other liquids of similar or lighter viscosity, so mineral oil, all sorts of waste oils, maybe even diesel. Water definitely, but this is definitely not intended for something corrosive as, let's say, gasoline or different concentrations of ethyl alcohol, perhaps. The video tutorial is going to be divided into the usual 3 parts, introduction, which we have pretty much almost covered. So the second part is going to focus on, it's going to have basically 2 sub-menus. One is going to be a general slow overpass or overview of various components of the pump, and then the main event will be an actual test, and then, of course, as usual, some conclusional thoughts. So let's add a little smaller addendum to the introduction. I want to mention just this in terms of age. This pump is definitely, since its original design as such, is definitely 20 years old. 15 minimum, 10 definitely. I'm a bit foggy on dates, and so because before we were heating our house with wood and coal, after we have moved to using heating oil and various stoves that we have for that. Okay, so let's move on to the next part of the video. First thing I want to mention or focus on is power or consumption. Because I'm situated or located in Europe, this pump is adapted to work on 220 volts AC. You can see this is the EU plug. The cable is almost 2 meters long, so it provides you a lot of flexibility on where you want to put or fixate the pump. Now, in regards to the rest of the components located on the wooden flatboard, this is basically just some sort of a connector that is screwed in securely by 2 Phillips screws on the board in order to prevent the cable from moving too much or moving not at all. This is a terminal block strip that enables the wires are joined together without the need of soldering, just using screws. Then the overall design is fairly simple. Here we have a very small miniaturized induction motor, which here with this gearbox, it transforms the high RPM coming from the motor into lower turns, and that provides the necessary torque, which then enables on this part the necessary suction. And all induction motors, they need some sort of a startup capacitor that you see here. This one in particular is, of course, a non-polarized type of capacitor, so this means that it doesn't matter how you connect the wires because polarity doesn't matter. As you can see from the information displayed on the capacitor, this is definitely an old one. This was made in the good old Yugoslavia, even though the design came from basically a Slovene firm at that time. So it's interesting that this still works or holds its capacity after so much time has passed. If we look at the wiring now, here we don't need to explain pretty much because it's, as you can see, very uniform in terms of color coding. So this would be your ground wire. So we have the capacitor that is grounded, also the motor with the gearbox. Now the blue wire, which would be your neutral wire, this one goes to one terminal of the non-polarized startup capacitor, and then from this point on it goes into this switch box, and from the switch box goes back to the terminal block strip, and then here the brown wire, which will be your live wire, goes to this white wire and goes back into the induction motor. The actual pumping position or the course of the fan is controlled by this very old, rudimentary, funny looking two-polar type of switch, which only has two positions, so on, and you could say an off type of state. I don't know if this is actually how it is. We'll see that when we will start the experiment. But I want to point out here is that if I was to add a three-polar type of position, so you could say a 1-0-2 type of switch, maybe I could even add another function to the pump, so instead of pumping liquid in one direction, it could also reverse the flow as well. But you know, I never needed this, so this is basically how it stays. Now the last part that we want to have a look at is this section over here. Now this plastic piece, I think this was salvaged from either a dishwasher or a washing machine from a really old unit. Can't really recall at the moment the brand or the model naturally. But this is the part that actually enables the pump to perform its magic. So this is the actual pumping part. And this is then coupled through the shaft, and through the shaft coming from the induction motor through this brass coupling. This is how it looks like. So basically the shaft from the pump is, I think, a bit slimmer than the shaft coming from the induction motor. This has a hole that is a bit smaller than the one on the opposing part or the adjacent side, and then you have two Phillips screws that are fixated to go down and secure both shafts as much as possible in order to secure the transfer of power from the induction motor to this actual pumping part. I have a spare piece right actually over here. So as you can see, you have the threads made into this brass coupling, so then when you tighten the screws, they don't fall out. So this is all designed with much care. Now we can finally proceed with the actual much more interesting part, the experiment. If you noted before, this is actually the hole for suction and this is for the pumping. But of course, in order to do this, we're going to need some proper tubing. I think these two will do the job nicely. And here I have a bowl of water that is going to be used as the liquid for demonstration. Now, before we proceed with the experiment by adding all the tubing and positioning everything that I won't get electrocuted, let's do just a quick check on what is the power consumption when under no load, basically. I think it's around 50 watts or so, but we'll see when it stabilizes. It's probably going to go up a bit or settle around this level. Yeah, so the power consumption under no load, so basically no liquid is being pumped, is around 50 watts. Okay, good. So after fiddling a little around with the tubing and positioning everything into place, we can start the experiment. Let's go! Come on, come on. Okay, so this is how it works, or basically what is the, almost the flow of liquid. In this case, I'm just using your regular tap water. As you can see in the tubing, you have some bubbles appearing. I don't think that has nothing to do with sealing, but it could be wrong. Yeah, so this is how it works. The consumption is interestingly a little bit less under load. A little more up close on the coupling and as well as the water running. So this pretty much, I think, concludes the end of this video tutorial. I hope you had a long wait in order for actual experiment to begin. It was a nice tease. Of course, as always, if you have any other questions, suggestions, constructive criticism, leave that all down below in the comment section, which is open, and I always invite you to civil discussion. If you like the video, thanks for liking it. If you want to share it or you have shared it, perfect as well. If you're a new viewer visiting my channel for the first time, thanks for stopping by. Please subscribe. If you're an existing subscriber, thanks for staying on the channel. Today has been the 26th of December 2020, and hope to see you in a new, better 2021. Merry Christmas and a Happy New Year, everyone.